Hi everyone, and welcome back to the discussion about the graph of trigonometric functions, sine and cosine. In here, what we're going to do is we're going to graph a sine function. Recently, I have like 15-minute long video to discuss what the graph of sine is. In fact, I have put a lot of additional information about it. All right. So I would like to apologize if it's long. It's just that I don't want to miss out some other informations. All right. So with that being said, let's learn how to graph it. So how would you graph? You should be focusing or basing it from this. Y is equal to A times sine of bx plus c plus d. Now the question here is why. Okay. If you remember the last video I made, which I hope that you watch it, this A, B, C, and D, these are your constants or numbers. So if you put that constant onto that letters, there would be changes to your sine function. All right? Because if there would be changes, that means the graph of the sine would be in different way. Like if we have the graph of a sine function in which the original function is sine x, the graph would look like this, okay? As I explained to you. But if I put a number here, like 2 sine of 3x, so what would be the graph of it? So there could be changes. So be familiar with that, okay? So what's the first step? The first step here is that you need to know the D and C. Know the D and C. D is the basically constant term of your function, or the number outside the sine function. C is just like a constant term, but that's inside the parenthesis. Okay? So in here, why you need to know the D and C? You will know if you're going to move to the right or to the left, upward or downward. Okay? You should know the D and C. Next is you're going to find the amplitude and period. Amplitude is basically the A, just this one, ah, A, in which it acts as a coefficient of your sine function. In here, yes, it is a coefficient of the function, but it should be always positive. Okay, it should be always positive. It doesn't matter if it's negative, it should be positive. All right. Then next is we're going to find its period, in which the formula is here, 2 pi all over b. And if you're asking me what's the b, that's basically the coefficient of the x, which is located inside the function of sine, or basically the input of sine. All right. Remember that period is basically like the total horizontal length of one complete cycle. All right. Then next, we're going to find the 5 key points using the period. But there's one additional information I said, that the starting point, in which the starting point will be called as the first key point. This first key point will be based on the input of the function. What I mean is that for you to find the first key point, or the starting point rather, you're going to base it here. This one. You're going to base it here, in which we're going to discuss that later. The next, after that, we find the 5 key points. You will trace these 5 key points smoothly. So that means you're going to graph it out. Then you trace those 5 key points and you can extend it. So yeah, these are like the general steps that you're going to do. So let's try that, okay? Let's try the original function, this one, okay? Like we know what sine x would look like, which is this one, right? This one, okay? So how are we going to graph it out? Just in case, or just in case. So let's apply the steps that I have introduced it to you. First step is, once again, you need to know the D and C. Okay, we need to know the D and C. The D is what again? Basically, the number outside the sine function. Okay, so yeah. Now the problem here is that it's not visibly given. It's nothing. It's just sine x. There's no number or constant term. So what does it imply? It implies that your D is actually 0. Okay, your D is 0. Not only because it is not visibly given, but it is also because that there would be no vertical movement or translation rather. Okay, like the graph will not move upward nor downward. Okay, so no V movement. Okay, I would like to write the whole word of vertical, but for the sake of the space, because I'm going to draw the graph here, I would rather just make it shorter as possible. Now, next for C, okay, C is basically like a constant term, but inside the sign, or basically inside the parentheses in the input. Now, you see, there's no C here, or a number that is beside the X. You know what I mean? So remember, again, C is what? It's like a constant term, but inside the sign function. So as you can see, it's just similar as the D. It's not visibly given. So your C is 0. So what does it imply? So for D, if there is no given D, okay, the D will become 0, in which there is no vertical movement. For the C, on the other hand, similarly, the C is 0, and there would be no movement, but horizontally. Okay, so long story short, since C is 0, that means there will be no horizontal movement, okay, or horizontal changes, or horizontal translation, okay? So that's it, okay? So you know the D and C, so the graph will not move upward or downward, all right? Two, you need to find the amplitude and the period. Let's start first with the amplitude. Amplitude is the easy one because the amplitude is basically the positive coefficient of your sine function. Okay, so basically the number beside the function. So here, just like finding the D and C, it's not visibly given. We don't see it. But in here, since we're looking for the coefficient of your sine function, it actually implies that your coefficient here, since yeah, despite the fact that it's not that given, it's actually there. Okay. Because you see, y is equal to sine x. It's just the same as y is equal to 1 sine x. Because 1 sine x or 1 times sine x is just the same as sine x. Therefore, your amplitude is 1 by 1. All right? So what does it mean when your amplitude is 1? Well, yeah, of course, the first reason is because it's based from the positive coefficient of your sine function, yes. And number two, that will be the length between the midline up to the maximum point and between the midline to the minimum point. So meaning, expect that if you're going to graph a sine function, okay, suppose it would look like this, okay? There's like a midline. So the distance between the maximum point and up to the midline would be 1 unit long. Likewise, the distance between the minimum point, okay, and the midline will also be 1 unit long. Okay? So that is the expectation that we're going to have. Okay? So that's it. Next, we're going to find the period. So period, again, is basically what? Sorry. Okay. Period is basically what? You just divide 2 pi by b. Okay? 2 pi by b. So what's the b? B is what again? The coefficient of your X. And just like, yeah, the rest of the other letters, it's not visibly given because it's not showing or it's shown here. Like there's no number beside X. But here's the thing. Just like how we find the coefficient of sine X, X, this one inside X here is just the same as 1x because 1 times x or 1x is just the same as x. Therefore, the b, in which is the coefficient of x, is your what? 1. Okay? That is your 1. So therefore, your period is simply 2 pi. So that means that, okay, if you're in the graph, okay, suppose this is the graph, okay? So in one cycle, which is from here to there, expect that the distance from it, horizontally speaking, would be 2 pi units long. Okay? So now you know. All right? It's important for you guys to understand what does your, this A, B, C, D means, okay? These letters. Because especially like what is your period, what is your amplitude? Because I want you to understand like what happens if your amplitude is 2 or 3 or your period is 2 pi or maybe it's pi or whatsoever. Because I want you guys to have an expectation what your graph will look like. Okay. So, okay, we have the second step. So the third step is we're going to find the key point. Okay. The key points. Now, remember that on the third step, let's have a recall. Find the 5 key points using the period. Yes. But remember, oh wait, no. Remember that there's this like additional information I include that the starting point will depend on the input of the function. So for us to find the first key point, we must base it on the input of the function, which is basically inside the parentheses. Okay. So let's start first with your first key point. All right. I think let's proceed here. Let's find the key points here. Okay. Let me just put it here. Let's put an arrow here. Don't worry, I'm going to erase the right side after we find all the key points. All right, the solution on the right side. So let's find the first key point. So the first key point is basing it on the input. Why? So for us to find the first key point, we're going to find the zeros of your input. What I mean is that, uh, right, we have bx plus c as the input of your sine function, right? So we have bx plus c. So what I mean by finding the zero, meaning you have to equate it to zero, then find your x. Okay? You're going to equate the input into zero, then you find the x. Now, here's the question. Why equate to zero? Right? Why do we need to do that if you're asking me? Because for us to find the first key point, number one, like assume that we have a sine function, right? For example, a sine function here, okay, which is this one. Let's just say you have an input of zero. So what does it mean when your input is zero? In here, there are two interpretations. One, you will know where is the starting point of the graph. What I mean by starting point, the middle part of the graph. Because if you're going to graph a trigonometric function, okay, you will always start at this point. Okay, you will not start here, then do this, or here, do this. No, you will start exactly at the y-axis. Whether it could be from here, or maybe from here, or maybe from here. Okay, so that's the first reason. Okay, second reason is that we need to find the what do you call this one? The what do you call this one? The y-intercept. Okay. So again, first reason, why is it that we need to have a input of zero? Okay. I mean, not reason, interpretation, sorry. What will be the interpretation if your input is zero? Well, number one, it tells you where would you start the graphing, okay, in which is actually located on the y-axis, whether if it's above it here, then you do these, or below it, or just, exactly where the x-axis and y-axis is pass to each other, okay? So that's the first interpretation. And two, you're looking for its y-intercept, okay? Because in graphing, not only you're going to find the x-intercept, in which you will see later what your x-intercepts are, but you will also need to find the y-intercept, okay? So that is why, for you to find your first key point, make sure that your input would be zero. But the question is, how would you make it zero? Okay, for us to find where would be the starting point of your graphing, in which it's actually located at the y-axis, and of course, what would be its y-intercept. So for us to find, not find, for us to make it zero, of course, we're going to find the zeros of your input. So if we have bx plus c as your input, we're going to equate it to zero, then find the x. Okay? So here we have x is equal to zero. X is equal to zero. Yeah, but let me explain further. So here, let me erase it. Okay? We have a sine x, right? Sine x. So the input here is only your x, that's the only input. So equate it to zero. So what does it mean? Since x is equal to zero, this is already what? The x of your starting key point. Okay, because once you found your x value, that will be the location of your first key point or starting point of your x coordinate. So with that, this is already your x. Okay, so this is the moment where you will find the y-intercept of the graph. Okay, so we found the x of your first key point, but we need to find its y. Okay, so how to do it? Just simply substitute the x to the sine function. Okay, so we will have y is equal to sine of, substitute x as 0, you will have sine of 0. Remember that it's just a number here. If there's no like an angle, which is usually what would be the input of sine function, usually it has a degrees because it has something to do with angles. But here, there's no degrees, it's just a number. That means it's in radians, okay? So, going back, we have sine 0. So what does it mean? Sine 0, if you're going to use your calculator, it means it's 0. So meaning, your first key point would be 0, 0. Now, if you're asking me, what does it mean when it's 0, 0? I'm confused. Okay? In first key point, of course, you're going to put it in ordered pair. Ordered pair would look like this, x, y. All right? And since because we're going to trace key points, of course we need to know the points, the x coordinate and the y coordinate, so that we can plot it out during graphing. So here we found out that we have x as 0, so we will put it here, and we found out that y is equal to 0, so you have 0, 0 as your first key point, which it implies that the location of your first key point is at 0, 0. Okay, so that's it. Now let's find the other key points. Now in finding other key points, though, you have to be careful because the way how you found the first key point is not entirely the same as how would you find the second key point. Because in the second key point, you would be now using the period. Okay, so why is that period is related to the second key point? So here's what you're going to do. So here, right, we have a period of 2 pi, right? So for us to find the y equals 1, for us to find the other key points, second key point, third key point, fourth key point, and the fifth key point, we have to use this one, period divided by 4, right? We have to use this one. So if you're asking me why, because when we found the period all over 4, we're going to use this not only for finding their x coordinate of their of their key point, but also it tells us that at what point where one complete cycle of the graph will be divided into 4 parts. Because remember, for us to find the 5 key points, if you remember last time in the video, okay, like for example, okay, let me have a short recap. For example, this is the graph, okay? In here, we have the first key point, the second key point, third key point, fourth key point, and fifth key point. If you're going to divide the graph by 4, here's what will happen. Oh, wait, no, no, no. How does it look? Yeah, this one is one. Here's what will happen if you're going to draw a horizontal line. Wait, horizontal line here. Ah, damn it. Wait, hold on. That's it. That's it. And that's it. As you can see, there are 1, 2, 3, and 4. So you divide the one complete cycle of graph into four parts. Okay? So with that in mind, for us to know where is it located, we're going to use period all over 4. Okay? So yeah, let's proceed. So period is just simply 2 pi and all over 4. This one we can simplify it because you see 2 and 4 are both divisible by 2. So 2 divided by 2 is 1 and 4 divided by 2 is 2. Therefore, you have a simplified answer of pi all over 2. So with that being said, we can use this to find the x coordinates of your key points, to be particular, from the second key point up to the fifth key point. So by how? So now that we have pi all over 2, I'm going to put it here. Right, I'm going to put it here. So since we have pi all over 2, what are we going to do? So right, we're going to find the x coordinate of your second key point. So here's what you're going to do. You're going to add the recent x value by pi all over 2. And there you will find your x coordinate. So recently, right, we have 0. Oh, sorry. So recently we have 0, right? So you're going to add that by pi all over 2. So 0 plus pi over 2 is just simply pi all over 2. That's it. Now, we're going to substitute that to your sine function. So sine of pi all over 2. So sine of pi all over 2 is what? So here, if you're going to use your calculator, it's actually 1. Okay? So therefore, the coordinates of your second key point is pi all over 2 and 1. Okay, so that is your first and second key point. Okay, now let's find the others, like the third key point. Okay, let's write the third key point here. Okay, let's find the third key point. So in here, let's first find the x. So the same way how you found the x coordinate of your second key point, all you need to do is just add the recent x by pi all over 2. So recently, we have an x of pi all over 2, right? So you're going to add it with pi over 2. So adding uh, pi all over 2 by itself, you will get an answer of pi. If you're asking me how, well, you have two fractions, right? And then the fact that both of them have the same denominator, so what are you going to do? What you're going to do, if they have the same denominator, just combine the numerators, of course, and by combining them, will be depending on the operation between them. So that means, since we have plus sign on the middle, that means we're going to add them. Then after that, you're going to copy their denominator, which is 2. So pi plus pi, 2 pi, then 2 pi divided by 2 is just pi. So hence you have pi as a result. Now we're going to substitute that to your y. So to your y, okay, we will substitute pi to your given function, which is sine. So sine of pi, that's it. So sine of pi, if you're going to use your calculator, is just 0. So you have 0 as a result. Hence, you will get pi 0. So that's the third key point. Now, for the sake of, having space, I'm going to erase the solutions except the key points, okay? We need to have that key point. So let me just put it here. This is the first key point. This is the second key point. This is the third key point. Okay, third key point. And let me erase them. Then let's find the fourth key point. So for your fourth key point, we will just do the same steps as what we did to the first, no, not first, to the second and third key point. We must first find the x coordinate. So again, you're going to find your x coordinate by the recent x by pi all over 2, okay? Like add the recent x by pi all over 2. So recently, we found the x as pi, right? So you're going to add it with pi all over 2. Now you see we have a full term and what do you call this one? And a fraction. So how would you combine them? Because overall, you have to add them. So here's what you're going to do. Okay, in the shortest way possible, I'm going to teach you this technique. You multiply the denominator and the number beside it. So we have pi on the left. We have denominator below, right? So 2 times pi. You have 2 pi, right? You have 2 pi as a result when you multiply them. So now that you have 2 pi, you're going to combine it to the numerator. So 2 pi plus pi, what's the answer? So you have 3 pi. So 3 pi, then copy the denominator all over 2. That's it. Alright, that is how will you combine, how will you combine a whole term and a fraction. Okay, just multiply first the denominator and the number beside it. So 2 times pi, 2 pi. Then you combine it to the numerator. So we have plus pi, right? So 2 pi plus pi, it's 3 pi. Then copy the denominator. Now we're going to find its y. Okay, so the same technique, just substitute 3 pi all over 2 to the sign. So we have 3 pi all over 2. If you're going to use your calculator, 3 pi all over 2 is just a sine of 3 pi all over 2 is just the same as negative 1. Therefore, the coordinates of your fourth key point is 3 pi all over 2 and negative 1. Okay? Then lastly, we're going to find the fifth key point. Let me just find the fifth key point here. Okay, so the fifth key point here, we're going to find the x coordinate as usual. Just simply add the recent x by pi all over 2. So 3 pi all over 2 plus pi all over 2. So notice that we have two fractions and they are the same in terms of denominator. Just simply just combine the numerators. So 3 pi plus pi, you will get 4 pi all over 2. And we have 4 pi all over 2. So what does it mean? So that means you're going to divide 4 pi by 2. So that would be 2 pi as a result. So you have 2 pi. That's your x coordinate. Now we're going to find the y coordinate of it. So just substitute 2 pi to your sine function. You will get sine of 2 pi. And sine of 2 pi, according to the calculator, you will get 0. So therefore, for your fifth key point, you have 2 pi, 0. Okay? So now you found the key points, the fourth and the fifth. Now what we're going to do is we're going to copy them here. We're going to move them here. Okay, this is the fourth key point, all right? Don't be confused by it. And this is the fifth key point. Then let's erase them and we will do the fourth step, which is to trace the key points. Okay? And by tracing it, we're going to do graphing. Let me just, what do you call this one? I think zoom out is the best way to do it. So yeah. All right, let me just put a label here so that you guys won't be confused. This is the first key point, second, third, fourth, and the fifth key point. Okay? So let's draw a graph. There we go. That's it. And then that's it on the vertical side. There we go. Okay, so first and foremost, of course, we're going to put the integers. My integers would be my key points, x coordinates of my key points. So since at the start we have 0, so that means this is 0 on the origin. Then we have pi all over 2. That will be the next number I'm going to put. So I'm going to put it here. All right, this is pi all over 2. All right, the next number would be just simply as pi. Then here we're going to put 3 pi all over 2. And here we're going to put 2 pi. Now, if you're asking me why should we use the x coordinates of the key points? Okay, all right. Well, it is because that if you're going to put integers to the graph, uh, make sure that they have a common difference. And what I mean by common difference, like for example, let me give you an example. I have a graph here, okay, and then the integers here. If you're going to take a look, I have 1, 2, 3, 4, right? Get the difference between 2 and 1. So 2 minus 1 is just simply 1. Get the difference between 3 and 2. So 3 minus 2 1. Get the difference between 3 and 4. So 4 minus 3, 1. So the common difference of the integers is 1. Okay? So what I mean by that is that when it comes to graphing, you're going to put integers, whether if it's horizontal, vertical, both, okay, or both rather. So in here, make sure that they are equally distributed. Okay, the same pattern basically. So that is basically the best way to explain it here. Okay, so right, you start from 0 and then pi all over 2. Get the difference between them. Pi all over 2 minus 0. Just pi all over 2. We have pi and pi all over 2. Get the difference between the two. Pi minus pi all over 2. The technique again, multiply the denominator by this. You will get what? 2 pi, right? 2 pi. Then combine it to your numerator. So we have minus pi. So that means I will have 2 pi minus pi. So 2 pi minus pi is just pi. Then copy the denominator, 2. So it's also pi all over 2. Okay? So the difference between 2 pi and pi all over 2 is just pi all over 2. Okay? And that would be also the same thing for the other consecutive integers. Okay? Get the difference of pi and 3 pi all over 2 will be also pi all over 2. Get the difference between 3 pi all over 2 and 2 pi, it will also be pi all over 2. There's no changes, which is good because they should be equally distributed. They must have the same common difference. If not, then you're not doing it in a proper way. Okay? Then, because of this, we can extend the graph, or not graph, we can extend the x integers. We can do that. Okay, we can. Forgive me. Okay, so yeah, we can extend it even more. So by how? Just simply add it by pi all over 2, which is their common difference. So 2 pi plus pi all over 2. I'm just gonna go direct to the point. Okay, I'm not gonna solve it here. So wait, 1, 2, 3. Wait, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Okay. So 2 pi plus pi all over 2, that's basically 5 pi all over 2. And 5 pi all over 2 plus pi all over 2, that will be just 3 pi. Okay. We will do the same thing to the left. Okay. But instead of adding, we're going to subtract because on the left side of the graph, it's negative. Okay. So let me just extend them. So 0 minus negative pi all over 2, we have negative pi all over 2. Then let's do it again. Negative pi all over 2 minus negative pi all over 2, that's basically negative pi. So yeah, negative pi. Here, this would be negative 3 pi all over 2. And lastly, here we are going to have negative 2 pi. So we're going to stop right here because that's the only graph I can reach. Let me put an arrowhead, my arrowhead here. Here we go. Upward and downward. Then, for the y-axis, since if you're going to take a look, their y coordinates 0, 1, and negative 1. So that means my integers would be, let's just say until 3. Maybe that's enough, until 3. So I will have like, how should I do it? 0, 1, 2, 3. So I'll have 1, 0, 1, 2, 3. 2, 0, 1, 2, 3, and then there, 3, okay? We'll do it also below, 1, 2, 3, so negative 1, 0, 1, 2, 3, negative 2, 0, 1, 2, 3, negative 3. That's it. All right, so yeah, because of that, we can now start graphing, okay? So here, let's start first with your first key point. Your first key point, it says here it's 0, 0. So what does it mean? It it not only means that your x and y coordinates is 0, but it implies that it's located on the origin. If the coordinate is 0, 0, meaning it's here. Right, it's here. Right, that's the first key point. Second key point is pi all over 2. So your x is pi, your y is 1. So if you're going to plot it out, it's actually here. Okay. So it's here. This is your uh, second key point. Okay. Then the third key point is pi 0. So your x is pi and your y is 0. So when your y is 0, but your x coordinate is given, that means the point is located at the x-axis. So we have pi here and your y is 0. So it's just located here. That's it. Ah, no, that's it. Okay. Then next, we have the fourth key point, which is 3 pi all over 2 and negative 1. So yes, we have an x value of 3 pi all over 2 and a y value of negative 1. So if you're going to plot them, it's located here, here. Okay, it's here. Okay, so it's located here. Okay, so therefore, it's here. That's it. Then lastly, we have the fifth key point, which is 2 pi 0. So just like for the third key point, you have the x coordinate, but there's no y. It implies that the graph would be only at the x-axis. So you have 2 pi, right? So it's here. That's it. Then what's next? You trace it. Okay, you trace it. So if I'm going to trace it, let's do it smoothly. Like this, and there. There we go. So that's it. You're done with the fourth step. Now, the last step is to extend it. Actually, there's no need for you to extend, but it's better to do it because we want to know at least what would be the graph, not only at the one cycle, but on the next cycle, especially on the left side. So since we started from the center going to the right, let's continue that pattern. So if you're going to observe the pattern, okay, we have like we start from here, right? The pattern is here, right? Middle, up, here, up, then middle, then down, then middle. So what does it imply? It implies that what do you call this one? Once you're already here, okay, you will go up, okay, for the next number. Then on the next number, you go down. Then on the next number, you go down again. Then on the next number, you go up. Okay? So this is the end of the cycle, right? Which is at 2 pi. So you start here, here. Right, sorry, you start right here. Then the next pattern, right, is you're going to go upward. Okay? So you're going to go up. Okay? We're going to go up like this. Okay? We'll stop until here, by the way. Okay? If this is like your second key point, okay, we're going to stop until there, all right? So we're going to stop at this height, okay? Then next pattern is you're going to go down, which is going the middle. So for the next number, we're going to go down, okay? Like this. And I think we're going to stop right here because, oh wait, no, I can still continue actually. Then the next pattern is you're going to go down, okay? Then when you go down, the limit or the height of you going down is depending on the fourth key point here, which is it should be until negative 1. So you're going to stop until here. Okay. So here, since this is the only part of the graph I can reach, I'm gonna put an arrowhead. Don't forget to put an arrowhead, okay? So yeah, that's basically it. That's how you do the graphing. Now remember guys, okay, remember that our amplitude is 1. Now, if you're going to take a look, okay, the midline is basically the middle part of the graph, which is here, right? Here, this one. From here to there, okay? Oh, wait, no. Okay, the midline is basically the middle part of the graph. This one. It basically divides the sine graph into two equal parts, horizontally speaking. Okay? Now, since, yeah, let me draw again the green line because it just suddenly vanished. Now, if you're going to get the distance between the midline up to the maximum point, which is here, up to the maximum point, what happened? You will reach 1 unit long. Likewise, if you're going to get the distance between the minimum point going to the midline is also 1 unit long. You see my point, guys? So our expectations are correct. Likewise, also for the period. Remember our period is 2 pi, right? 2 pi. So if you're going to get the, wait, hold on, let me just, no, I can't. Wait, let me just go back. Wait for a second. Hold on. Wait. I'm just going to erase the green line. Right? Just give me time. Forgive me. I can't, there you go. Okay. So anyway, going back. So right, our period is 2 pi. So remember, 2 period is just basically a horizontal distance of a one complete cycle. So right, you start from here, which is at the 0. Then you and then what do you call this one? You will stop until 2 pi. So from here, 2 pi. Yeah. So from there, from 0 until you reach 2 pi, if you're going to get the difference, pi minus 0, you have 2 pi units long. So that means you are also we are correct. Okay. The graph should the horizontal distance of one complete cycle, which is this cycle, okay, okay, if you're going to get the difference between the x coordinate of your first key point and the fifth key point, the x coordinate of your fifth key point, which is 2 pi, so 2 pi minus 0, 2 pi units. So we are correct. Okay, the period is in fact 2 pi. Okay, so that's it. Okay, we're correct. Now, let's do one more part. Okay, let's extend it even more. Like, instead, we're done it going it to the right. Let's do it to the left. Okay. So when we go to the left, we will do the pattern, but in reverse way. Because remember, right, the pattern here is basically middle, up, down, middle, right? So again, middle, then up, middle, down, middle, right? That's the, oh wait. Sorry. Hold on. I didn't notice that. But yeah, as I was saying, right, the pattern of the sine graph is middle, up, middle, down, middle, right? So now, if you're going to do it on the left, we'll do it in reverse way. We'll do it middle, then down, then middle, then up, then down. Okay? Middle, going to the left, down, going to the left, middle, going to the left, up, going down to the left. Okay? So middle, down, middle, up, down. Okay? It's the opposite of what we did. So let's do that. Okay? So here, this is our starting point. So first, we will go down. Okay? And remember, the maximum height, okay, or the maximum height or the maximum depth is until 1 unit. Or basically, since the minimum point stops until -1, so that's the part we're going to stop. Okay? So we're going to stop until here. So -1. Then you're gonna go up, okay, the middle. So it's here. Then you're gonna go up, okay, upward. So again, maximum height will reach until 1 unit, 1 unit long. So in this case, you stop until 1. So here we will have like this, okay. Then lastly, you go down, which is here, the middle, okay. Then if you're going to continue the pattern, okay, but just make sure that pattern is just reverse of the original pattern. So you'll go down. Then here I'm gonna stop right here, and I'm just gonna put an arrowhead. That's it, because that's the only graph I can reach. So yeah, that's it. That's the graph of sine x. I put it into too much detail, not only because I want you to know how to graph, but I want you to understand. Because after this, on the next part, we're going to graph these, 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 and these. We're going to graph them all. All right. So once you understood this one, like what are the steps, now we're going to do it on the other examples as well. All right. Now what else I can add here? Okay. So yeah, that's basically it. And now the fact that I would like to add one more. The fact that your d is equal to 0, your c is equal to 0, right? It means that there's no vertical movement. There's no horizontal movement. So it makes sense, okay? which means that the graph will you state like this. The graph will not start from here, then you do this, or the graph will not start from here horizontally, then you will do this. Okay? So it implies that if there's no vertical, no horizontal movement, it just simply stays here. Okay? Just stays there. Doesn't go up, doesn't go down. Okay? So yeah, that's basically it. Now you know the steps on how to graph the sine function. Now on the next video, we're going to do that on the next examples. Okay? Because the video here, it's getting longer. Okay? So right now, I hope you gather much information. All right? Like how to graph and why do we do this? Because I didn't put the information here why you do this, why you do this, why you find this, why you have to do this. No, I didn't. Okay? I just basically verbally explain it. Okay? So that is all guys. So I hope to see you soon on the next video. See you soon.